Well, good afternoon. This is still Comp 422 and Comp 620. Today we're talking about web security and cross-site scripting and some other attacks you can make on the web. A reminder that there's an online exam due next week, Tuesday by noon. Uh, may want to use SQL injection. There have been some questions about that assignment. I strongly recommend you go back and look at the slides. They're posted on Blackboard. All the answers are in the slide. If you look at the slides and you still don't understand, just email me, call me, text me, get hold of me somehow, and we can talk about it or Zoom or whatever you need. And another reminder that there's an exam a week from Monday, 17th, whatever day that is, 16th, but it's coming up. So it's about a week and a half away. I'll tell you more about that. Some of the material we've been covering is not in the textbook. There is, of course, all sorts of information on the web should you want more than what the slides or the lectures on what YouTube provide, but you can look there. And as usual, there will be nothing on the exam that was not covered in class. Okay, talking about the web. We're going to briefly go over how the web works and then how you can attack that structure and how you can defend yourself against attacks to that structure. Okay, two parts to the web everybody knows: hypertext transport protocol, transfer protocol, HTTP, and then the hypertext markup language, HTML, both of which were developed by Tim Berners-Lee, now Sir Tim Berners-Lee, several years ago. And hyperlinks, by the way, were actually out there many years before. I remember reading about hyperlinks long, long ago, but they didn't have the web, so it didn't make too much sense. Formats. When you have a web link, there are a particular format. It starts with the scheme. How are you going to access HTTP, HTTPS? It could be file, if you're getting it from a file on your machine, or FTP, ://, then the name of the server, possibly : port number. As we discussed, there are port numbers. The default is 80, but if you don't want to use port 80, you got to use something else. Then a path name, where in the file structure of the server are you going to find this, and then the file name, and then possibly a fragment. A fragment tells you just a bookmark within the web page. So you might have a web page with sections in it, titles. Think about Wikipedia. If you go to Wikipedia, there are certain sections. You can bookmark a section. So when you click on it, you go right to that section. Also, because the web is also used for distributed programming, you can have parameters. Parameters are separated from the rest of the URL by a question mark, and then variables equal value. So you have name value pairs separated by ampersands. So you can have multiple name value pairs separated by ampersands. The values could be in quotes. And of course, sometimes they are base 64 encoded in long, weird numbers, but that's how it works. And so if somebody was at the acme.com website at this particular page, note that this file name doesn't have an extension. That might be a directory. If you don't specify the directory, it goes to index.html, and then passing it those parameters. When you click on a web link or type in a web link and enter it, the browser sends a request off to the server using HTTP. HTTP sends the requests in ASCII text. Everything's in straightforward text. You can read it if you happen to have something that will capture the information that was sent across the link. But if you have a chance to look at it, it's each piece of information is separated by an enter, enter, and then it starts off with a method. We'll cover what that is. A file name, what are you trying to access? The HTTP version, HTTP/1.1, and then end of line, and then options. There may be multiple options, each one on a separate line, followed by a blank line, which is really just two returns. And after the blank line, then you've got the data. Any data you might send, not always sending data from a HTTP request to the server. Yes, question. Oh, carriage return line feed. Carriage return line feed. Carriage return is the enter key. Depending on what system you use, how long it's been around. Some systems terminate the end of a line with a carriage return, some with a line feed, some with both. The world has not been able to unify on that, but it's out there. So typically, any one of the combinations will work. Okay, and I put this little down to the left arrow to represent a enter key or return. So an example might do a get slash the page you want, HTML, use your version end line, and then an option which is host, and give it the name of the site. Return, that means that makes a blank line, and that will go off to the server and say, I want to get this web page, and this is the server that I expected. You have to put the host. The host used to be an option, but now it's a required option. That is because many web servers serve multiple websites, and they have to know what website are you looking at. Just because it goes to this machine doesn't mean it's that machine's website. There are many very large web servers, Amazon Web Services, and many others that service many websites. There are multiple methods. Again, the method is what goes here in the beginning. You can say what you want this to do. Get means I want to get a web page from the server. Put means I want to put it, or post means I want to send the information to the server. Those are the ones that use most of the time. Head is used just to get the information. It's like a get, but it doesn't ask the server to send the text to the file, just the header. That's used for a lot of these systems that check web links to see if it's any good. You might send a head request because all you want to know, can I get the data? Does it exist? And a head will return a header. It tells you, yes, it exists, but you don't need to see the file. You just want to see, does it there? Some of these are there for web maintenance delete. You can delete a file from the server. Typically, that requires options to specify your authority to do that. There's options if you want to get options from the server. Trace is that you can find information about the server. Okay, when the browser sends that sort of request off to the server, of course, the server responds back. There's a header followed by the contents of the file, be it HTML or a graphics file, or whatever information you requested. There's a header. Again, it starts with the one header line. There are options, each of these things separated by end of line or carriage return or carriage return line feed, and then a blank line followed by the file contents, the HTML or whatever it is that you asked for. Here is an example. We've asked for a file, comes back status 200. Okay, that means everything is happy. And some information, the date, the server, what type of machine the server is running. When was this file last modified? We're sending you a file, and what is the timestamp on that file? That's important because some systems will ask for the file only if it's been changed. So you want to know how long it is, connection closed, whether we're going to close this connection when we're done or not. And then what type of data are we going to see? There should be a blank line in here before the HTML. It doesn't show up very well because, again, blank line separates the data and the options. So, yeah. So who made these slides anyway? Should be a blank line there. Stat. Before bracket HTML and after content type, because content type, these are options, a part of the header, and then HTML is the text, and there should be a blank line. I'm not going to bother to try putting it in, but yes, there's ought to be a blank line between there. The slide is slightly incorrect. All right, codes, 200 OK is the happy message that says, yes, everything is fine. We are sending you the file just as you requested. everything went okay. There are some informational ones that you don't see very often. The redirection ones, just get a 300. One of them is moved permanently. It's not here, it's over there. And then I mentioned you can request it if it hasn't been updated. The 304 not modified is a return from the server saying you already have the most current version of that file. It's not going to send it to you again. You can redisplay it. Most browsers, most all browsers that I know of, keep a directory of the files that you've looked at. You can see this history when you look at history. In your browser, you go up and look at the history. That's just showing you the files that it has saved. So if you go back and you try to get those again, it may say, do I have the current version? And if it does, it just tells you 304 not modified, and your browser can display the cached version that it has. Then, of course, there are errors. 404 file not found. Everybody's seen that one. Bad request. The format's incorrect. There's unauthorized and forbidden. I'm not exactly sure what the difference is between unauthorized and forbidden, but somebody can probably look that up. Those are, you can't get here. Payment required is obvious. And then gone. Gone is interesting. That seems to be different from not found. I assume gone means it was here, but it's gone. And then there are server errors. 500 means something's wrong, didn't work well. I see those messages a lot if you have a program on the server that is running and is going to generate the return file. Often you have a PHP program or some program that generates the HTML, which is then sent back. If for some reason that program gets an error, you'll see a 500 internal server error, meaning your program blew off and you're not going to get anything back. So we come to our first clicker question of the day. Oh, where are these? Anybody need a card? Very well. Oh, forgot it. I didn't think I could. Okay. There we go. Okay, everybody's got an answer. Well, I think they have an answer. All right. There. Oh, everyone but one person voted B. B is the overwhelmingly popular test. Oh, some people online, much people online thought it was JSON. That's wrong. Nope. The answer is, in fact, B. It's ASCII text. You can look at it, and we will talk about systems that capture that information and allows you to look at what's going over the net. So HTML or HTTP is rather nice because you can just see the stuff going by. All right, moving on, maybe. Okay. Frequently, there are multiple files in what is shown on a web page. Every graphical image is a separate file. HTML just has the text along with all sorts of formatting information, possibly referencing a CSS cascading style sheet that specifies formatting. And so there's many files involved in your typical web page, even a very simple web page. So once it goes out and gets the first HTML page, the browser scans that and says, oh, I need additional files, and it will go out and make a request to the server to get those individual files. Again, it requests them using HTTP. So basically, the system creates a network connection, wants to connect to port 80 on the server, sends the GET request to the server. The server sends the header and the contents of the file back to the client. The client reads that HTML, finds needs for graphics files. If it specifies there's an image, it will tell you where to get it. and all sorts of other things you may need, cascading style sheets, JavaScript, any other files you might need for this, and it sends a request to the server to get those, each making another request. Now, HTTPS, S is in secure, uses the transport layer security. Used to use SSL, but SSL is old and deprecated, and we don't use that anymore. But transport layer security is a hybrid security. If you remember, that means it starts off using asymmetric or public key encryption, uses the certificate of the server, sends a random key over to the other side, which is then used afterwards as an AES key. And then everything is communicated, encrypted with AES, a new key, of course, for every time you log on. Now, it encrypts the data. It does not encrypt the network headers. When encrypting the data would also imply the HTTP headers, but not the internet protocol headers that tell it where it's going. If you encrypted those, you send it to the next router, the router wouldn't know what to do with it. So you can't encrypt those. But it does encrypt to the internet protocol. Everything inside that packet, other than the headers, is data, and it will encrypt those. It does not encrypt the, it does encrypt the HTML headers, HTTP headers, everything in there, but not the internet protocol headers that it used to route it. And as I mentioned, non-secure HTTP uses port 80. HTTPS, the secure version, runs on port 443. That's how it knows what you're supposed to do. So you can connect to port 443. It requires encryption. Note, by the way, most servers, if you go off to port 80 with an HTTPS request, it goes, oh, you are in the wrong place, and it'll return a 301 move permanently status. Your browser goes, oh, it's not here, it's there, and it will then go to where it was specified. So your server will generally say, oh, wrong port, look on port 443 for this, and then your browser makes that adjustment and sends it. So all these things happen automatically. You forget the S, sends it off, says, oh, you forgot the S, and then corrects it. Okay, I think I mentioned secure socket layer has been around for a long time. It's deprecated, and there's not a big difference from it. Everything uses TLS, transport layer security now. Now, to create a connection with TCP, it is a 3-step process. Just to create, use with TCP, the client who wants to get the client sends a request called a SYN or a SYN request to the server saying, hello, I want to connect. The server sends back a SYN ACK request saying, I got your message, and it sends some parameters about the connection, how much you can send before I stop and stuff like that. And then the client acknowledges that it got that request from the server, and then we'll continue on with whatever. If at that point it's requesting a file from web server, right after the ACK, we'll send a data file, or data packet with a HTTP GET request in it to get something. So it starts with the SYN request, client to server, a SYN ACK, server back to the client saying, I got it, here's some parameters, and then the client acknowledging it got that message, and then they continue on. Now, if you have transport layer security, it makes it a little bit more complicated because not only do you have to make the network connection, but then you also have to make the keys. You have to create the keys, send the certificate back and forth. So again, we start things with RSA, which is a asymmetric, and then let's look at the picture. It's easier to, well, maybe easier to understand. Client sends a request, I want to connect. Goes, oh, yes, you can. Then says acknowledge. The server says, okay, here is my certificate. This thing checks this, gets the certificate, makes the key, sends it to key. Then we got that. Then we start sending data. So there are 1, 2, 3, 4, 5, 6, 7 the seventh message starts sending data. So there's some overhead going back and forth. Now, the server sends its digital certificate to the client. The certificate includes the public key of the server, along with some other additional information. If you made certificates earlier, you know that you have to specify your name, organization, stuff like that. If it's a certificate for a server, it contains the server's name, www.acme.com. That will be in the certificate. So when a browser gets a certificate, we'll check and see, oh, if I went out to www.acme.com and I got a certificate from it, does the certificate's name match where I went? If it doesn't, it may have some concerns. If it matches, everything goes along fine. Doesn't match, it may give you a message about that, telling you something's not right. Also, certificates can be revoked. Sometimes somebody finds out the private key for a certificate, and now it's no longer secure, and the company wants to discard that certificate, buy a new one and use that, and doesn't want to ever use the old one, and they will have the certificate authority revoke that certificate, and they put it on the revocation list. A client should check the certificate by going out to the server of the certificate authority, getting the revocation list and saying, is this certificate on the list? If it is, then don't use it. You've got a problem, but at least display a message. Unfortunately, this is not always done. A lot of systems do not check for revocations. There are a bunch of options when you do this. You can specify what encryption algorithms you want to use. Typically, again, they use RSA and AES, but you don't have to do that. You can use triple DES or whatever you feel like, whether you're going to use the GCM mode. Remember, that's the glycos chaining mode. Last name, I'm not sure, but you remember there's blockchain and other chain modes, ciphers, that which one are you going to use? And there's also the secure cookie flag. We'll talk about that on Monday. Now, there's, in addition to TCP and UDP, there's another protocol out there that's becoming very popular. Let's get rid of this. There's the QUIC protocol. I have read that QUIC is not an acronym. It's simply the name of the protocol. Okay. But it sits over there in where TCP would be. What it uses UDP, does not use TCP. Almost everything else, all the regular web always use TCP. QUIC is a protocol on top of UDP that adds a little bit more features and makes it more efficient. The big thing about the QUIC protocol is, of course, that it's quick, right? It tries to be more efficient. It's particularly useful for HTTP 3, which is the latest version of HTTP. It's been out there for several years now. A good example here is the startup, as we showed earlier, between a client and a server using TCP. You know, it sends messages, okay, send the client, hello, but QUIC assumes you're going to use transport layer security, which, by the way, you can see TLS, transport layer security, kind of sits in there. It's not required, but it's typically used because almost everybody now is encrypting everything going over the web, and why wouldn't you? So when it sends the initial hello, it then, when it first replies, it sends a certificate. So we can then use that and other information. So you can then pick up encryption key and send that along with data, and then just keep on going. So it's much faster start. Questions about that? Oh, okay, applications on the web. I'm going to mention this before, but basically, you've got HTML and JavaScript in your browser. HTML specifies how the file is supposed to look. Cascading style sheets specify the format. Then JavaScript is a programming language that runs in the browser. There are others that run in the browser, but JavaScript is by far the most commonly used one. And then PHP or JavaScript or Java or other things can run on the server as a program. And so the browser sends files to the program on the server that can do whatever that program wants to do. So imagine you have some application for a company or so. The user enters data on a web form, you get the box, press enter, the JavaScript gets that. There's a JavaScript statement, usually on change or on collect. If you click this, it calls this JavaScript function, which does whatever it feels like, typically gets the information from the field, formats it up, and ships it off to the server. The server then gets that data. The server gets that, starts the program that was specified, passes it the data. The program then generates new data and passes it back to the browser. It can pass just a file, often in XML or JSON, just file. And then the JavaScript in the browser can take that file and display it on the screen in any way it feels like. Or sometimes the server will just send a whole new web page. And that's displayed. Another question. That's okay, there we go. This is not really, this is a question wanting to know what is your experience with web pages in JavaScript? Just so I have an idea of what the people in the class have done. I understand that if you're watching this at night on YouTube, I'm not going to understand what you are, but hopefully people in class will give me a random sampling, which has some relationship. Okay, everybody. Answers up. All right. And people online responded. Okay, very few, a couple of people who've created a website. Well, let me just get the numbers. Okay, 17 online, 7 in class. Adding them together, I have 3 people who've done a web page, 12 people a website with HTML, 6 people a website with server-side programming, and 3 people who've done none of the above. Okay, so it gives a lot of you have done at least a web page with HTML and website. Some have done server-side programming, but not too often. All right, it's okay. None of this is involved in this class. You will not have to write web pages unless you're an undergrad in Comp 422, then I might have you do something. Okay, a little review of how HTML does things. HTML, again, has things in brackets, the greater than less than brackets. There are all sorts of tags. P is in paragraph. Script starts the job, typically JavaScript. This is going to be the default. You could go like script space and specify as maybe Visual Basic or something. There are other languages you can use. Almost always is JavaScript. And then you can have IDs. IDs are just a tag, just a name. I'm going to call this paragraph thing. And then there's the text inside the beginning paragraph. So this is the text. There's the begin paragraph, end paragraph, all the ends start with /p. And then there are parameters. Parameters are always a name equals, and then a value. The values are always in quotes, always in. And you might have this in a JavaScript where you go document, document being the HTML document. That is the root, the whole thing. Get element by ID says, I want to find the element that has the ID thing. And here there is one. So it's going to be dot inner HTML. It says, I want to change the HTML of that object. And I'm going to change it to evil and corruption. It used to be mom and apple pie. Even the bracket EM is emphasis. It's going to emphasize evil and corruption. So it's going to change mom and apple pie to evil and corruption. And anything could be there. Now, one of the big problems we mentioned before, and it still occurs in web systems, is using untrusted data. You get user input. Watch out that the user input doesn't get executed. Sometimes you will concatenate user input with data that you got, user with other things to display information. You have to be careful because it may contain JavaScript actions or other stuff that you don't want to use, you don't want executed. It can come from many places, cookies, databases, user input. Generally, usually comes from user input somehow, and it may find its way, may be stored and come back. And it can be merged and split and recombined with trusted data. But once you have untrusted data merged with trusted data, the result is untrusted. Okay. Cross-site scripting, often abbreviated XSS, is an attack using untrusted data in a JavaScript situation. It's very common, it's a very popular attack. It has been used for years. It was all your favorite social networks, Twitter, Facebook, MySpace, YouTube, all the others were using it. Nowadays, after a few dangerous situations, these companies have got smart and prevent the cross-site scripting attacks. But they weren't always that smart, and a lot of people got hit. Basically, though, it happens when you mix up user input, text formatting, any web page, the text and the action, the JavaScript are all in one file together. So problems can occur. Okay. Yes, and basically, again, problem occurs when you start to interpret user-entered data. Here's an example. Okay. Say we have a box in a web page, and it says, enter your name. It sends it off to the server. So it sends it off to the server. Say the server is example.com, and it's going to go to myapp.php as the program on the server. It's a PHP program. It's going to execute and pass it the data. And there's the transport type, the server, the file name, question mark separates the parameters. User equals Ken. So there must have been a field that said enter your name, and sending it as user, the data was Ken. There may also, of course, any HTTP request, there's going to be headers involved. That's not important at this time. Cookies, those aren't important in the issue we're talking about now. This is what I'm saying. Basically, though, you're going to send what the user typed in. Then the server might come back and say, hello, Ken. That would be the typical thing to do. Put the Ken, concatenates it in there, sends this back to the server and displays it on the screen. You've seen that. Now, let's imagine that the user doesn't type in just their name. They type in their name, bracket, script, bracket, alert. I'm going to use a lot of alerts. Alerts are very simple. They pop up a message. You see the pop-up box, it's got okay, puts whatever you put in here and quote, you hear a message. Many of my examples use alerts because they don't cause any damage. They're very simple. But you could do a lot of other things. You could cause other damage to occur in the website. You can change a lot of how the web page works. In my examples, I'm just using alerts because you can run them on your browser and they're safe. An alert just pops up. If you get a pop-up that says, gotcha, you've been had, it could have been a lot worse. All right, here's an example. We have this web page. Not much to it. One file. All right, all the web pages start with HTML. Head, there's the header. Inside the header is some script, which is JavaScript, and I have the function show name. It just gets element by name ID or in stuff. Down here, we have an input box, which is an input field. It has the ID in stuff. it wants text and has this on change. On change means when you change the data in that box, you type in something, press enter, it's going to go call the show name function up here, show name. And then the show name will grab what you put in there. It goes to get my name, gets the value, and then rewrites the document saying, hello, whatever you typed in. And then let's, how do we do for time? Oh, let's give it a shot. Oh, okay. Stand by, online people. We're going to lose you. Okay. Hang on. Okay, we'll get you back in just a minute. I'm going to try a demonstration. If I can. Should have had this all prepared. Oh, okay. Let me share my screen again with. All right, you should see this web. This is the web page that you saw on there. And so if I type in my name, student, and it says, hello, Joe student. We'll reload that. But let's just say we'll type in Joe, try to at least spell it correctly. And then we'll go script, alert, parentheses, quote, we call him bracket, end script. Yes, and try that. Does that look good? I spell it all? Yes. And it comes back and says, you have been hacked. Okay, and replace it. Yes, we have a question. Oh, yes. I wonder why. Sorry, the people in class aren't seeing this. That's interesting. Okay, enough of that example. Yes, if you want to see it yourself, there's that HTML. We will go back to the PowerPoint slides. Yes. Oops. Oh, now I've done it. Nope. There's where I wanted to be. Okay, hang on, online people, we're coming. All right, we should be back so again, if you go out to the slides, copy, paste this into your notepad, save it as whatever you want, .html, double click on it, pops up in your browser, and you can run it. Now, this one, of course, is vulnerable. How can we fix this? That's why we're here. We're not here to learn how to be a good hacker. We're here to learn how to defend against hacking. So that's best done by constraining what can be in it, stopping people from entering anything. Just specify the format that you want the input to be. HTML5, which is the latest version of HTML that everybody's running these days. There's a type field. You can specify, I want a number. I don't want letters, just want a number. And you might specify a minimum maximum value for that number. And other things. You can specify if it's a URL, you can say this is an email address and it has to look like an email address, or a URL and it has to look like a URL. Or you can specify a regular expression pattern, which I am sure all Comp 422 students who've taken the theory class should be able to generate a regular expression. I hope so. And then you can catch errors and all sorts. So if you're expecting data, you might say, I don't want to see brackets and test the validity. There are two very useful methods with this. You can specify the element you're interested in and say check validity. The check validity function method checks it and says, if it's okay, it returns uh, true. If it's not okay, oh, excuse me, it's invalid, it returns false. Okay, it checks this. If it finds an error, it returns false. Otherwise, everything's fine, it returns true. Report validity is very similar, but it displays an error message. So just check validity, returns it, and the JavaScript can do whatever they want with bad things. Report validity lets the JavaScript do whatever it wants, but also displays something on the screen telling you you've made a mistake. Get out of here, bum. Okay, and here's an example of it. Down here, I put pattern. I said we can have upper and lowercase letters from A to Z and also lowercase letters from A to Z. Repeat it as often as you want. You can look up how pattern is a regular expression, but it's pretty simple. You could add numbers in there, whatever else you want. Notice there are no brackets. And so with this one, you can, well, if when you click or change the field, calls show name, gets the information, and then says, wait, is this input field the value that we got? I'm going to call report validity on that. That is the input field. That would be this field down here on the screen. Is that good? If it is, then we just do the hello username like we want it. If it's not good, then we'll change the message. There's a message down here. Change that message to bad input. And so you'll see the message bad input. And I'm not going to run this because I don't want to go through the trouble of finding out why it doesn't show to people in class. But you can run it yourself if you like to. All right. Now you may ask, okay, these are all sorts of attacks you can do in the browser. You can enter things in, do things in your browser. Isn't that your browser and your input? I mean, aren't you attacking yourself? Well, yes. The most persistent type, the most common type of cross-site scripting XSS attack is non-persistent. That is, you do it on your site, but it can be very dangerous. Basically, you're running whatever the user input there, and it can come from other sources. A common source for this is to send somebody an email saying, go out here and look at this, or on a search screen, something coming back. Or if you have a social media site, you can store something with JavaScript, and well, that's not non-persistent, that's persistent. We'll get to that. Here's a good example. Okay, Alice uses bobsite.org and wants to look at this. So Carol knows that Alice uses bobsite. So Carol sends an email to Alice saying, oh, look here at this link, bobsite, search, look for puppies, bracket, script, source equals this, calling a JavaScript file from this site, sends it to Alice with the title Cute Puppies. And again, talked about earlier, this is what's going to be executed when you click it, but doesn't have to be what's displayed. What's displayed on a link in an email does not have to be you can specify what you want displayed and what you want executed. Frequently, you'll see emails that say, click here, H-E-R-E. But that's not what actually, it doesn't go here. It goes to some website. And here is what's displayed on the screen. And then behind that, you can specify the website. So you might have a title that say cute puppies, whereas it actually executes this. And this is going to do some cross-site scripting attack. It's going to we execute the authorization stealer, get Alice's cookies. We'll talk about cookies on Monday, and send those off to Carol. So now that Carol has that, which is the authorization that Alice chooses to get on, Carol can now log into Bob's site as Alice and use Alice's account. Then there are stored or persistent cross-site scripting attacks. This is where the information is saved on a server and appears to somebody else. This is the example I was showing. You might do this with a social media site where you store information out there. Somebody goes out and looks at it. It's displayed on their server. The JavaScript is executed and does something on their local system that they probably don't want done. All right. Oh, I missed this board. Let's see. The nice thing about this is you can put it out there and hundreds, maybe thousands of people will look at that file and execute that JavaScript. And you can get lots of people. And sometimes the systems are really nasty, and they'll part of what they do is copy that uh, malware, the cross-site scripting attack, into other files. So it keeps propagating all over the place. DOM is domain object model. That is the web page structure. It's a trees-based structure. You've got all the elements you see, all the paragraphs and all the input fields, and it's based as document anyway. You can have attacks on that. You can change fields, change cookie information, and that can be persistent or not. Okay, cross-site scripting is definitely a problem. It's not going to go away. It's still one of the top problems. It is browsers are just basically insecure because they do that. They understand JavaScript, and when you give them JavaScript, they run it because often you want to run JavaScript. And you might have pages that have brackets in them that aren't attacks. Another separate problem besides cross-site scripting, similar, is parameter tampering, where you change some of the parameters in a web page. Web pages, again, when you have a commercial web page, you fill out a form, you press send, it takes that information, the JavaScript sends it off to the server with certain parameters, name, value pairs, separated by question marks, ampersands, yes, sent by ampersands off to the server. Now, that data might be changed along the way. You can have network proxies or web proxies. Network proxy or web proxy is either a hardware box or software where your information from the web, before being sent off to the server, it sends it to that program. That program looks at it and then sends it off to the server or not. That program, now sometimes these are valuable. They're used to filter information that they don't want going. You might have a proxy server that acts as something like a firewall, and it gets things that doesn't allow it all to go out or allow things out that it doesn't want, but it inspects the information and then sends it all. Sometimes it allows you to stop. There are several proxies out there. We will be using some in this class. Here are two very popular ones. OWASP. We're going to talk about OWASP more today. OWASP, Organization for Web something security. I can't remember. Go out to the website, OWASP website, and it'll tell you what it stands for. But OWASP is a website dedicated to providing information about web security. It's very popular, has a lot of good information out there. They also have the Z Attack Proxy, ZAP. It's a free proxy. You can run that and then capture all the information. So you type something into a web page, hit send, and then the proxy will pop up and show you what you sent. You can look at it, press the button to say send it, or you can look at it, edit it a little bit, and send it along. Editing is important because that means just because the browser thinks it sent everything correctly doesn't mean it will get to the server correctly. It may be stopped in the middle by some sort of web proxy. In addition to Z, there's also the Burp Suite. I don't know who makes these. Burp Suite Community Edition. That's free. Community Edition is free. And you can get it from there. These are two very popular web proxies. Okay, so let's imagine we have a web page and we are selling, what are we selling here? Books. We're selling books. Okay. Displaying textbooks for Comp 620, Section 1. And you say, oh, okay, this is a required textbook. You want to buy one of them. You want to buy it new and all the other things. And then you add selection to the cart and it sends it off. If you look at the URL up here, it's going to send a book ID, which is probably the ID sent for this particular book, telling you what book it is, and quantity one, which came from here, and the price, which comes from here. Now, problem is it's sending the price in a way that the user might be able to modify. Just because, again, the browser sent it correctly doesn't mean it will get to the server in the same format. So again, the browser is going to send off to there, run this program, give it the ID, quantity, and the price. A web proxy might change the price. And if it changes the price, you could get that book for really cheap. You can change it instead of being $59.95, change it down to $1.95 and get it a lot cheaper than everybody else did. Oh, we have another clicker question. Find it. All right. Oh, that's it. All right. Let's see what people brought. Oh, everybody in class voted C. Everyone in C. Online, most people voted C. Can be viewed and edited by a proxy. That is correct. Uh, no, only link address can be seen. If it was HTTPS and secured, you could see the link addresses, but you couldn't see the data. Most of these web proxies can get around HTTPS, although you may have to answer some messages in your browser that you should never ever answer. Some of the if you go to HTTPS, some of the web proxies will come up and the browser will say, oh, hey, we got a certificate, but it's a certificate for the web proxy, not for where you want to go. You want to accept this? And for educational purposes, you might say yes. Otherwise, never ever answer that yes. Oh, okay. What are we doing here? Oh, okay. Everybody can see that, and we'll share the results. Like I said, most people will. Okay, everybody see avoiding the problem online? I just had one of those internet wonders where everything's blinked on me.
Yeah, I can see it.
Okay, good. We got affirmation that you can see this. Avoiding the problem. As you mentioned previously, we talked about SQL injection. Don't trust user input. The application should, in this case, should get the price of the book from its database. Don't rely on the user sending that. It's fine for the user to send the quantity. It's fine for the user to specify which book. I mean, that's necessary. But after that, it should look up the price of the book in the on its server. Another thing you might show is look at this. We have different books order. We have 2456, 2457, 3801. We might happen, whatever happened to 2458? So you could go out there and change the order number. It wasn't your order, it's somebody else's order. Let's see what get information by somebody else's order. Might be able to change their delivery address to deliver it to you. Sometimes people can guess information. People make the URLs easy to guess. Let's just imagine that I had an assignment out on the website and you could find the solutions for hw3sol.pdf, which I put out there after assignment 3. Where might you expect to find the answers for assignment 4? Because I might, trying to be ready, put it out there before the file is actually due. I might go out there and create the assignment, put the assignment out there. I have the solutions because I usually write those when I write the assignment, put them out on the web page. And where would I put it? Well, it doesn't take a lot of brains to say I might look at hw4sol.pdf. So you might go out and look at that. You might have noticed, look carefully at the last exam, there were a web page that you had to go to. It was some pretty obvious name followed by 4 random numbers. The 4 random numbers would make it very hard for you to guess. So yes. So you don't have to make it. A lot of times you'll get web pages that are a long string of random numbers. Typically, it's the hexadecimal version of a random number or base 64 encoding of some value. That's so it's random. You cannot guess what the next web page is. There are systems that will go out there, look at your website, take out all the nice, easy to remember English names of the pages, replace them with long, weird numeric, alphanumerical names, go through all the links, change those to the corresponding alphanumerical names. So it's very hard to guess what the web page is going to be called. That's a good idea. Now, sometimes there are hidden parameters in a web page. It's obvious if you have a box there and you enter some value in the box and you press submit that it's going to be sending that value. Sometimes there's other hidden information that it sends so that the browser can specify something to the server that it may need to know to do this correctly. An example here, we have type hidden ID equals the admin. Oh, remember that HTML is not real secret. Users can see it. You can always right click your web page, say view source, and it opens up a page and shows you the source code and see all these things. Also, comments. Web page is going to, now if you're creating a web page, we have a big web page in a system, you want to put comments in there like, what are we doing? What does this JavaScript function do? And other things, particularly if you're going to do something that's a little different, weird, put a comment out there so other people in the organization will know, what are you doing? What does this mean? It's like commenting a program, put comments out there. But you don't necessarily want the comments to be shown to everybody who looks at it because everybody can view the source of that web page. Here's test your passwords, bitch. So there are systems that will go out there and strip all the comments out of a web page. They will compress it. They might even obfuscate it. It's not always necessary to go full obfuscation, but they might make it difficult to read. Obfuscation is a process of going through a web page or JavaScript or other programs and rearranging it so it's very hard for humans to read. You changed all the variable names to like V1, V2, V3, and so forth, which programs have no problems with. And sometimes they'll do things like they will replace loops with recursion. And I've taught for 30 some years, and I know students hate recursion. So yeah, nobody's going to capture that, figure that one out. Okay. When you create a directory, a folder on your website, you have a bunch of files in there. If you don't specify the file name, if you go www.acme.com/folder name, nothing, then it will go out and retrieve the file index.html or default.html if they're out there and display that. A lot of sites have. Generally, you have an index.html on the root directory of your website. So if somebody goes to www.acme.com, it's actually going to go out and retrieve index.html from acme.com and display that. But if you do not have either a default HTML or an index.html and you don't specify it, many websites will then list the contents of that directory. You may not want everybody to see the contents of that directory. I've made mistakes like that before on the class website, and you can go to the class website and see everybody's file. For instance, the last time it was text files with weird base 64 encoding. You could see everybody, but no, you can't on that one because there is a index.html on that web page to prevent that. So the answer is always put an index.html file in every directory so you don't release information about what's happening. Sometimes the web server allows you to turn off that ability. See, never do that, which is always a good idea. Just run it that way. All right. Yet another question. Does he never stop? Oh, there we go. Okay. Sorry, I am being challenged by Zoom. Uh, ah, there. It finally does what I asked. I'll not mention the 15-minute session with Zoom support line this afternoon, but they fixed it. Oh, okay. Okay, you've done that. Okay, well, I got that's enough. All right, well, online, almost everybody thinks it's D in class. D is a popular answer, but B is even more popular. And the answer is D, all the above. I mentioned you should store sensitive information only on the server. Don't put it in the web page such that they might be able to modify it. Again, avoid using sequential numerical numbers. And you can use random page numbers. That random page names, that all those keep people from understanding what's going on your website and makes it more secure. Okay. Vulnerabilities. The OWASP, Open Web Application Security Project. That's what OWASP stands for. I knew we'd get to it. Is a very useful site. OWASP.org has lots of information on protecting web applications. If you get in the business of protecting web application, go out to OWASP and read the pages, find out what's happening, what are the most common vulnerabilities, and go out and fix them. As I mentioned before, your website doesn't have to be ironclad. You just have to be difficult to hack. If you're significantly more difficult to hack than the other websites, most criminals are going to go on and try somebody else. You're too much trouble. You don't have to be faster than the bear, just faster than the other guy. And I've got a bunch of stuff here from OWASP. Okay, well, a couple years ago, but they should go out and check again. Broken access control, cryptographic failures, injection. We know about injection, insecure design. We'll go over these important ones in a minute. Security misconfiguration, outdated components. Yes, there's been an update, security update to something, but you didn't put the security update in your system, so now it's vulnerable. Authentication failures, that's one of the many problems you can have in letting somebody log on. Integrity failures, not logging. Yes, not logging. That's typically happens when errors are occurring. Your system detects an error, detects something bad is happening, and doesn't do anything about it. Or the programmer who wrote the system carefully writes a log entry whenever bad things happen. But nobody in operations ever looks at the log, so they don't ever see these errors. So you're getting attacked left and right. The application programmer who wrote your system is going, oh my gosh, look at this, putting all sorts of errors in the log, and nobody looks at them, so nothing ever gets fixed. And then server-side request forgery, which we will talk about. Yes, and if you don't want to read everything, there's the cheat sheet series at os.org, and you can look at that, and it has all sorts of these things, all sorts of problems, and you can go down and look at them. You should know this one. Oh, let's just skip this one. Vulnerability. What's vulnerability? Well, it's vulnerability. It's injection. These vulnerabilities, injection. We mentioned there was injection. That's for obviously SQL injection and cross-site scripting. It is the problem of taking user input and putting it someplace where it gets executed. That's both SQL injection and cross-sites. So the answer is C, all of the above. There are, again, rule number 0. But hey, these are computer guys. They start counting at zero. Never insert untrusted data anywhere. They say not here, not there, not an attribute. Just don't do it. Rule number one, HTML encode before intruding. You can HTML encode it to try to that helps. What is HTML encoding? HTML encoding is where you change certain parameters. An ampersand becomes ampersand AMP semicolon. Everything starts with ampersand. Less the ampersand LT semicolon. It always starts with an ampersand character, a couple of letters, and an ampersand. And this encodes things. There are functions in most of your popular languages, particularly in JavaScript, that will HTML encode things. So it converts it to this format, and that sometimes prevents things from happening because the system doesn't interpret the quote as a quote, just sees it as. You can also, for each one of these, put the hexadecimal value of that ASCII character. In other words, a quote is a hexadecimal 27, so it's ampersand, pound sign, or hash X. X is in hexadecimal 27. I won't ask you what decimal number that is, but you should know. There, okay. All right. Now, some people say, well, we won't allow any brackets. That's not always good because sometimes you're going to want to have brackets in there. You might want bold and emphasis and strong and italics and underline and things like that, which are relatively safe. And it might be used to display things properly on your web page. But you want other things, though, script, object, embed, link, those should not be allowed. Those are definitely going to cause you some trouble. There are other systems you can, and there are only safe attributes. These are some attributes that are definitely safe. That's hypertext length, it's source, style, and other thing. All these are sort of okay. It makes challenging, and there are functions to do this. I mentioned encoding the input. You can encode the input, JavaScript. Encoding, so you can code all these things. These are particularly dangerous in red. Then there's a whole bunch of other characters that you want to. And there are methods to do this. You encode URI, takes the input, and then returns it HTML encoded. And of course, there's a decode URI that undoes that. Another popular problem, encoding errors before inserting the data. Yes, you need to put it, you're going to have untrusted data in generated. So if you need to do this, if you need to put that data, and sometimes you got to do it, you want to put it in a quoted data field that has been JavaScript encoded. And you can code characters as such. JSON is a file format for sending data between servers and browsers, or the other way around. It works very well with JavaScript and PHP and other things, and you create the files. So often you can have a web page where you type in some information, your JavaScript does something, sends a request off to the server does some processing, looks at the database, sends back some information, maybe a table of information, and it's formatted in JSON, which is just a table, and then your program gets it and can do whatever it wants to, and the server typically reformat and display it on the screen. Important, again, watch out for intermixing data and instructions. Cross-site scripting and cascading style sheets. Cascading style sheets provide information about how HTML web pages should be displayed. You want to watch. That's also a place where data can be malware can be attached to a cascading style sheet. You got to watch that. Yes. So yeah, here's a cascading style sheet. You might say, oh, it's the background. You can specify the background image for your web page. And instead of having image, you might have JavaScript and do an alert. So that actually, again, I do alerts all the time because they're easy. You don't do anything. Again, creating links Got to watch out to make sure that the links are correct. There's a is valid URL that tells you whether this is a good looking link or not. Check that before you use it. And sending data to attacker. There is the XML HTTP request command, we'll talk more about on Monday, that sends data. And there's the same origin policy, which says I can only send data to the server from which I got the web page. That helps keep you from sending things someplace else. But there are things that go around that. If you have an image, say you have an image on a website and you want to get that image from, you can get that image from another website now. So if you go out to www.acme.com, you get a web page and it says display this image. The image may be in www.widgets.org, and you'll go out to widgets.org and get that picture and display it. That's nice because sometimes you're going to display big pictures that you find on the web. Maybe I find the pictures on Wikipedia, and instead of showing them myself, I just provide a link to Wikipedia. It's got the pictures, and I can display it on my web page. But the request may not necessarily be what you think it is. You might have a source going off to a page, www.evil.com, that is waiting for these requests, and then the name of the file request is not a name at all. You are sending it something you've captured by running on the browser, information you have that the JavaScript has access to, cookies and other information that you have, and it will just put that information as the name and send it off. Now, this evil website doesn't care what the name is. It's going to take that name and knows that the program is sending data. It'll always send back the same picture, so everything looks good, but you get okay. Good with all this. We covered a lot of material over cross-site scripting and HTML and many other things. Okay, remember, online assignment is due Tuesday at noon. You have to go out there and log into some websites. All the information to do these websites is in the slides, particularly the slides of SQL injection. If you're having problems, go back and look at those slides again. If you're still having problems, contact me, send me an email, text, phone me if you have to, and we can go over it and Zoom together if you need to. Also, there's the dark web. Now, let me say something about the dark web. I do not expect you to go out to the dark web and do evil things, which is very possible. I'm sure that you know the difference between right and wrong. And just because there's the option of doing something doesn't mean that you should do something. But a lot of times, as a computer security expert, people will talk about something on the dark web. And so I have this assignment so you'll know what the dark web is. So it's not this mysterious something out there, I don't know what it is. No, it's just a bunch of web systems using the onion routing that you have had experience using. So you can go out there, take a look around, be very careful, don't do anything dangerous. The only thing you really have to do is go to that one forum site, look up the Comp 422, Comp 620 page, find the name next to your number, and put that in Blackboard. And remember, of course, that this assignment worth 100 points is split up into a 60-point thing and a 40-point thing that'll appear on Blackboard, and then I will add them together. Computers are good at that. Any questions? And a week from Monday, we'll have our next exam. Our second exam in the course will be a week from Monday. I will talk about that next Wednesday, a week from today. We will also review for that exam. And if for some reason you don't think you'll be able to take the exam on Wednesday, if your grandmother is getting ready to die for the third time, please let me know ahead of time. All right, that's it for today. Any questions online?
No, sir. Thank you.
Okay.